And we are. Welcome, everybody. And this is our seawall inspection report from Mr. Martin.
Okay.
Take it away.
Thank you. Well, we're using high technology to record low technology because I'm using a set of slides that I set up many years ago, and eventually I'm going to get it all electronic, but for now this is what we have. So, as you know from your program materials, my name is Martin Pinckney with American Engineering here on the island. I usually try to give a little bit of history when I get started with these. Our company started back in 1978. That was when Deltona, the developer of Marco Island, was still building in the process of building seawalls. And Darryl March was an engineer with Deltona, overseeing some of that construction. He left Deltona and started his own business called Marco Island Engineering, which in 1982 was sold into a company called Anchor Engineering. And then Anchor Engineering later became American Engineering. I came to work on Marco Island for Anchor Engineering in 1989, and started even from the very beginning. I was involved in somewhat in either seawall design or inspections. Actually, Darryl March is still around. He's in my office every day doing design work. But at any rate, my connection with seawalls goes back even further because my father was a dock builder and seawall builder in coastal South Carolina for many, many years. And I worked for him for a few years in the early 1970s, building both docks and seawalls. So I have a sort of long history of dealing with seawall construction and inspection. That's sort of the background. Now, I'll go on with my explanation of the seawall situation on Marco Island. This first slide that you see is actually not Marco, but it's out of Capri. And you can see there is a riprap revetment on the shoreline here. When I was at Capri, each property owner built their own shore protection, whether it be a riprap like this or a vertical seawall. Whereas on Marco Island, they were all of the modern developed lots where the seawalls were built as part of the original infrastructure, whether it be Marco Beach subdivision, which constitutes the majority of the island, or Marco Village, a smaller subdivision, which was developed about the same time in the early 60s. Those original seawalls were built as part of the infrastructure by the developer. However, once someone buys a lot, then that seawall becomes their problem, not the city's or any other body. Now, this is a shot I took several years ago of a seawall in South Carolina, not one my father built, but it happens to be a combination of timber and vinyl plastic. You can see that they made this seawall follow the natural shoreline. But on Marco Island, as I'm sure you know, the shorelines were created for the most part. And the seawalls, therefore, are much straighter. They follow geometric shapes. There are, of course, some natural water bodies on the island that were there before, like Fredericks Bay, Roberts Bay, Smokehouse Creek, which were kept but lined with seawalls. Now you can see this is typical for Marco Island, and in fact typical for South Florida in general, that reinforced concrete is the material of choice for seawalls. This little sketch just is illustrating the forces that act on a seawall, which it's technical, but it reflects on the kinds of issues that develop with seawalls. This line represents the vertical sheet piles, as they're typically called in the engineering business. And you have soil pressures that are trying to push it out. You have soil pressures that resist the movement. And of course, you have hydrostatic pressures, wave actions, tidal forces. And on most seawalls constructed in this area, you have this tie rod that is put in there to help restrain the seawall. The reason they use a tie rod is it simply is an economic choice. You can build a seawall without the tie back, but it would have to be much deeper embedded in the soil in order to be stable. So that's the reason why we have the tie rods. Now, this shows a typical construction of a concrete seawall. You have, they're designed as a tongue and groove, just similar to tongue and groove flooring. There's a groove on this side, a tongue on the other side. They are reinforced steel rods cast into concrete. In this picture, you can see they're stacked because typically what the contractor
Thanks
does.
for holding. We look forward to talking with you soon. Please hold the line. We'll be right back with you.
Scrapes the place on the ground, level place, puts down plastic sheeting, puts the seawall forms down. But typically the forms are made out of steel, and pours a set those slabs, and come back the next day, put some plastic sheeting, and they up for another set of slabs, and that will have enough for the job. This shows some at in the yard. They were made in the yard. These are actually much more heavy duty ones that were designed for something like two layers. Now, the autonomous operation started in 1964.
Thank you for holding. We sincerely appreciate your patience. Please stay on the line. We'll be back in a moment.
The grand opening for Marco Island was the first seawalls that they made reinforced concrete, but they had a wood rail beam. This is one of the tie rods that are based. Now, they didn't make a lot of seawalls that way, but they changed the design fairly soon to make the whale beam instead out of wood be out of reinforced concrete. And this is a typical one. They built many miles of this style in the late 60s, mid to late 60s. Now, this is looking at that same type of seawall. Just looking down, you can see the whale beam here. The whale beam is where you have the tie rods from in this particular design. And this is actually a shot from the land side. It happens that this seawall, this lot was not maintained by the owner when I took this picture, so they then wash out of soil, so it's just convenient. You can see this tie rod coming through. And you can see it, perhaps you can tell it's got heavy scale rust on it. That was an issue with that type of seawall, that because the tie rods were down as low as they would get inundated with high tide from time to time, so salt would get on them. They were plain steel. There was rapid corrosion. So they changed the design after a number of years. I think probably starting, this is just a guess, but maybe around 1970, they eliminated the whale beam and instead put the tie rods from the cap. And here you see one of the tie rods coming back from the cap. That happens to be a galvanized one, but I've also seen plenty of them that were plain steel. So you still had corrosion issues. Now this is called a T-pile seawall, and this was put in by Deltona in certain locations where they wanted a heavier type of seawall. This happens to be down at one of the streets off of South Barfield. I'm not sure exactly which one, but you can see in the distance Cape Marco going up, and when it was before all the buildings were in. So this dates the picture, but at any rate, it's called a T-pile wall, and these are the T-piles here. I'll show you how that looks. This is the front of the T-pile, and there's the back of the T-pile, and you can see one of the tie rods going back. And in this diagram, you can see why it's called a T-pile, because each pile is in the shape of a T, and then the sheet piles are placed behind the T, the cap is poured over the whole thing, and you see the tie rods coming back to concrete deadening in the soil. Now, the last design that Deltona built, this represents, it's got a heavy cap. The slabs are 5.5 inches thick, and they use tube encased tie rod. This picture was taken somewhere near where we are, over in the streets that come off of Goldenrod. And you can see this is one of the tie rods behind the cap. You can see it's got a plastic tube over it. It's still a plain steel rod, but at least it has a plastic tube to provide some corrosion resistance. This picture is going to show it kind of dark, but this is a much more modern construction, but it's still the same basic principle, except that the tie rods now have a double layer of corrosion protection. They are either galvanized or coated with epoxy, and they have the plastic sleeve over. In this case, it's red plastic. So you have a double layer of protection. The failure of tiebacks due to corrosion has pretty much gone away. Now, this picture is just a diagram showing, an engineering diagram showing the reinforcing steel, tongue and groove slabs, and how the tie rod comes from the cap back to a dead man. You can see in this section through the cap, you can see there's longitudinal steel and stirrups that reinforce the cap. Now, well, I originally put this to illustrate where certain type of seawalls were built, but never really did fully fill that out. Now, as we all know, seawalls fail, and there are basically 4 modes of failure: tieback failure, buckling failure, and general deterioration. Go through these one by one. Tieback failure is typically caused by the tie rods rusting through, or they rust down until it gets so small that they can't take the forces and they snap. Now, in this particular slide, this cap is curved and it was originally straight. It's because you had some tieback failures, and I don't know if it shows up, but there are cracks you can see through the cap where the cap is cracked because of its flexion. Another typical situation here with tieback failure. What happens in tieback failure typically is you have a first one will fail. Just it rusts until it gets so small that it can't hold the forces, and it will snap, and then the tie-back rods on either side of that would suddenly have additional load applied to them, and they might snap, so you get like a domino effect. The whole seawall begins to rotate out. That's why it's called cap rotation, until the dirt falls away, relieving the pressure, and then it maybe doesn't need any more. Just depends on how much the toe is embedded, whether you get a complete failure or not. Here you see a heavy rusty tieback rod. And this is one of those late Deltona type cubic fish rods that the plastic cube has gotten hit and cut probably by a bush hog. And so you can see now the rust begins. All right, toe failure is when the embedment of the toe is reduced, usually due to erosion, to where there's not enough material to keep the toe from rotating. In this case, the toe is rotated out and the entire seawall is sunk down. In this case, it sunk down, but it didn't rotate because they were piling to keep it from rotating. Now there's one where the toe rotation constitutes a pretty complete failure. The buckling failure when the slabs actually break in two, typically when the salt from the water slowly penetrates through the concrete. Concrete is not impervious to the movement of water through it. They do use a special concrete mix for seawalls that is supposed to reduce that effect. But nevertheless, eventually the steel within the slab rusts to the extent that it's no longer enough and the slab breaks. This one that's broken enough, you can't see the break, it's below the water, but that's what's happened to it. I think this is the same picture, the same one from a different angle. Now here you can see where this part has not failed, this part has, and so it's just broken the cap at that point. And this one, this part failed and this part held. Actually was an expansion joint there, which is what allowed this part to hold. You can see one of the tieback rods exposed by this hole. Okay, general deterioration is just a slow process of the steel within the slab and within the cap rusting, and the concrete itself deteriorates from exposure to the elements and age and weathering. Now in this picture, this is looking at a seawall cap, and you can see this fine crack running along there. That's because the steel in the cap is rusting and expanding. You know how steel rusts, it expands, and it's just pushing the concrete apart. In this case, you see the same thing happening, but it's just a more advanced state of deterioration. Now, in this case, there's just some general deterioration of the concrete itself. You can see the rattling of the concrete, some cracks occurring. This is one of the piles at a corner of the seawall, which is the same thing is happening. The reinforcing steel within that piling is rusting and spalling the concrete. This is one of those whale beams that we mentioned in one of the Deltona early designs, and the same thing is happening here. The steel in the whale beam is rusting and cracking the cap. In this picture, it's already spalled the concrete completely, and you can see how the steel is swollen from rust. This is one of the expansion joints that Deltona put in. They weren't very successful. They were designed so that one side of the rebar was fixed in the slab and the other side was supposed to slide, but it eventually rusts, and then when it rusts, it jams and doesn't slide and spalls the concrete. In this picture, we see everything deteriorating a little bit. The whale beam is coming apart, the slabs themselves, the cap is coming apart. these tension plates that we get to later are rusting. Now, another thing that is something that always has to be contended with is soil loss through the joints. These tongue and groove joints are interlocking to make the slabs function together, but they're not watertight or sand tight typically. And so every time tide comes in and tide goes out, it takes a few grains of sand, and eventually you get these holes forming. Now, when they build these, they put some filter fabric behind that joint to keep the sand in, but that's going to deteriorate over time. Some lots have drainage pipe penetrations. This one needs some attention. Unfortunately, if you have to replace a seawall, the city requires the owner to address the pipe penetration if you have one when you replace the seawall, even though it's a city storm drain. All right, so here are a summary of the different failure modes and the causes for them. We mentioned the rusting of the tieback rods. A couple of cases I have seen where the tie rod actually pulled out of the concrete of the cap, and a couple of times I've seen where the dead men were not big enough and they actually moved in the soil. Toe failures usually occur because the profile of the canal changes gradually over time and reduces the amount of embedment of the slabs. Not always, but oftentimes toe failures occur in storm events, either due to wave action or additional hydrostatic pressure on the seawall. The buckling can be age or inferior quality of construction, and of course, general deterioration is a combination of age and weathering. On this particular seawall, I took this picture right after Hurricane Andrew. The waves topped over the seawall, and you can see some problems here where you can see a crack in the cap there. This section failed because the two things happened. The waves undermined the toe, and they also washed out the backfill, so the dead men were unable to provide any support. These were some that were rejected and waiting to be hauled off. I guess the concrete strength was not up to par, would be my guess, why they were rejected. Okay, so repairs. There are lots of repairs that you see on existing seawalls on Marco Island. We'll go over the various types of repairs. Supplemental tiebacks is very common. This particular one, this line right here is the original whale beam with tiebacks that Deltona put in. These were put in by Deltona as kind of a retrofit. And they supposedly had tube encased tie rods. You see those sort of randomly in different places around the island. I think, I don't know, but I think that owners had to request Deltona to put that in because of concerns about the original tiebacks rusting. Now here you see a stacked whale. There's an original whale beam down here. There's another whale beam on top of it. So each one of those has a set of tie rods and dead men. This is how the stacked whale is done. Sits on top of the old one, and you got a new tie rod with a dead man. The new tie rods, of course, have been put in with a corrosion resistance.
429.
Here on this one, you see the original whale beam, and you also see tension plates, which we'll get into next. This one has the original whale beam, the Deltona retrofit, and another whale beam up here. So three different sets of tiebacks on that one, three different sets on the last one. Why you say, well, Oftentimes when seawalls change hands, new owners are concerned how long my seawall will last, and they get somebody to look at it and end up doing some kind of reinforcement on it. So this is the original whale beam, the stacked whale beam here, and the tension plates here. This is a stake shows that's a property form. The tension plates were basically retrofitted tiebacks with a steel plate on the outside of the seawall, a threaded rod with a nut, and to tighten it up, and then they put that cap over to cover up the nut. And that's kind of what it looks like in an engineering diagram. Here's the dead man. Another form of that, and a simple heavy washer here. And this is one of the those, you can see where they broke a hole through the seawall, and they put this tube encased galvanized rod to go back to the dead man. It's one of those tension plate retrofits. Here you see concrete piling driven to help support the seawall. There's another example. They're often used in this fashion to try to support the toe, because the piling can be driven either touching the toe, or they put a sack of concrete mix between the piling and the seawall to help provide a pressure point. Here you see the whale beam, the original whale beam, the short stacked whale, tension plates, and wooden piling in this one. Toe reinforcement is usually done with piling like this. Like this, here you can see this seawall had already, the toe had already rotated, and we put these in, driving down, touching that bottom of this, which is a risky business. Here you see how that's done. You've got a crane. This happens to be a vacant lot, which makes it a lot easier to do. Crane with a pile driving hammer driving in these concrete piling. Now, riprap is a type of seawall reinforcement that is extremely effective, because it just provides a mass of stone to resist any movement of the seawall whatsoever. Now, in this case, they use very large rocks, almost like small boulders, and it's a very effective means of supporting the seawall, but it is, some people don't like it because either they don't like the look of it, or because if they were putting it down. The city will allow you to use riprap, but they want it down below the low tide line. Now, screw anchors is one of the more recent things that have been used to reinforce seawalls. This particular one was made out of stainless steel, 16 feet long, with 3 helices. They're more commonly made out of some form of galvanization, galvanized steel. Just an engineering diagram. And this is a model showing how they would be installed. You can actually install them from the outside by coring holes, and we have, this is a track and a hydraulic motor that screws it in. So you see with a hydraulic motor rather than electric, they can actually do it underwater. They put one down low, put one up high, and one mid in this particular model. And it's basically just an earth screw that goes in. So the advantage of it is you don't have to dig up the yard to put a new dead man. The disadvantage is they don't have as much holding force as a typical concrete dead man, just because of the size of it, but it can be engineered to be effective. This was some real ones that were put in like that. There's actually 1, 2, and I think there's a third one we can't see behind there. And there's a can't see it because the picture's too dark. There's a crack that goes up through here, and they put that big tension plate in 3 of those screw anchors to just restrain that seawall. So there are a variety of miscellaneous repairs that are done. New caps, new French drains to help deal with the problem of soil loss. This is just kind of a dumped gravel on a vacant lot. And here they kind of sculpted it. Those trees that close to the seawall are not recommended because they can add some additional pressure on the seawall. So eventually, nothing lasts forever. Eventually, replacement is required. Here you see in this picture, this is a replacement seawall and a couple of original seawalls on either side. And a newer one here, an older one here. This is a vinyl one, but we'll have a better picture of that later on. This illustrates the steps that you see in certain places. Deltona stepped the seawalls up. They made them a foot higher, the seawalls that were on Caxamas Pass or the Marco River. And the city today still allows that 1 foot differential. There's a maximum height and a minimum height. It's a foot difference. Now, this picture's kind of dark, but this one over here, these are all replacement seawalls. This one's down at the lower height, and these other two are at the higher height. And that's another shot of a step. This one shows a piling with drilling, and then they put a very large cap to encase over the piling. That's not very commonly done. Another shot showing the seawall slabs being poured on a vacant lot. That is something, I think they still allow that, but it's been sort of back and forth with the city whether they would allow that, someone to utilize a vacant lot with permission to pour them instead of pouring them in a yard somewhere. Contractors like to do it this way because it reduces the cost of building the slabs when you can build them very near to where you're going to set them. But personally, I think you're better off with slabs built in the yard because you get better quality control. Now, we've shown you mostly concrete seawall, which is the preferred material, not just Marco Island, but I would say pretty much all of South Florida. If you drive around Miami, Fort Lauderdale, where you see the canals, you'll see most often concrete seawalls. It's just like, it's just a choice, you know. In other places, wood is used, treated wood, or other materials. Marco will not allow wood or steel in their seawall ordinance, but they will allow vinyl, concrete vinyl, aluminum, and composite. So there are a few vinyl seawalls on the island. This is one of the first ones put in. And these, that's what they are like. They're actually, they're interlocking. They're very much like the steel sheet piles that you may have seen around an excavation somewhere, except they're made out of plastic, which obviously they don't have the strength of steel, but they do make them in different weights. And when you put them together, they have that in and out look. So another company came up with an idea of making one that had a flat face to it, and this is an example of it. It's got a concrete cap. These are the vinyl seawall sheet piles. Here you can see where they've made it up to an existing concrete seawall, and you can see that it really blends in very well. Now they make, that's the other end of it, right at the corner. Now they are made out of vinyl, and they interlock the same way. It's in a U shape. So this void in the middle is typically filled with gravel, or in some cases they fill them with concrete for extreme service. And they make pieces to go around corners. But the vinyl is has not been that commonly used. Concrete still seems to be the preferred choice, and of course the cost of various types of materials varies with the cost of the raw ingredients to go in there. Generally speaking, I would say that the vinyl seawalls probably cost more than concrete. The one exception is probably when they put, some people put vinyl on the outside of the concrete. They don't remove the old concrete. They put vinyl on the outside of it. That's permissible. because the state rules and the city say that you can go out a maximum of 18 inches to in front of an existing seawall when you're doing repairs. So if you put it in front of it, you save the cost of removing the old and the cost of disposal of the waste concrete from removing the old. But that hasn't been done that often. It's been done in a few cases. It, of course, results in a shoreline that's not continuous. You will have a shoreline projecting out of that particular lot. So for that reason, it's not that popular to do it. So the questions that I often get when I have one of these seminars live is, how much do they cost? How long do they last? You know, the cost varies with time, and I don't have the latest numbers, but I would say it's considerably more if they're putting it on a lot that already has a house on it for obvious reasons. They have to work from the barge. Working with the barge is slower and just riskier. But we're probably talking, just as a general rule, between $400 and $500 per running foot for replacement seawall. How long do the seawalls last? Well, I like to say that Marco Island is a sort of a living laboratory because various types of construction have been tried and by Deltona and other people. And so you kind of can see what has lasted and what hasn't. There are still a lot of the original Deltona seawalls in existence on Marco Island. They, in almost every case, in most cases, let's put it that way, they have already been reinforced in one way or another to keep them from failing. The ones that are being built now with the city seawall ordinance, if the contractor, the seawall contractor follows the quality control requirements in the ordinance, in my opinion, there's no reason why you couldn't have a new seawall last 50 years. We have the ones that Deltona built that are, some of them already over 50 years old, although, like I say, most of them have already been reinforced. So that concludes my presentation. I hope you learned something.
Very well, thank you, Martin. If anybody has any questions for Martin regarding the presentation, please feel free to send them to the association and we will get them over to Martin for him to answer. So thank you very much for attending and have a good day.